For as long as we have been a species that can think, we have been telling ourselves a story about the universe. It is the great, overarching story of creation, a narrative that science has patiently pieced together over centuries of careful observation and brilliant deduction. We have come to understand this story quite well. We know it begins 13.8 billion years ago, in the hot, dense, singular moment of the Big Bang. We know of the long, cosmic dark ages that followed, before the first stars ignited and filled the universe with light. And we have a beautiful and elegant theory for what happened next. A slow, patient, and gradual process of cosmic evolution. A story of small things slowly coming together to make larger things over the immense and silent expanse of eons. We believed we had the basic chapters of this great cosmic book in the correct order. And then, we built a time machine. This time machine is the James Webb Space Telescope. It is the largest and most powerful eye on the cosmos that humanity has ever created. Its great golden mirror was not designed just to see farther, but to see further back in time. Because the light from the most distant objects has been traveling for billions of years to reach us, to look out into the deep cosmos is to look back into the deep past. The Webb was designed to be our historian, our archaeologist. Its primary mission to capture the faint, ancient light from the very first galaxies to ever form, to witness the very first chapter of cosmic dawn. And in its first years of operation, it has succeeded beyond our wildest dreams. It has looked back into that primordial darkness, and it has seen the first light of creation. But it has also seen something else, something unexpected, something that does not fit our story. It has found great, luminous, and shockingly mature galaxies, shining brightly in an era where only cosmic infants should have existed. It has found something that, according to our own elegant and well-tested story of the universe, should never have existed. Before we journey back more than 13 billion years to witness this beautiful and profound cosmic paradox, I would love to know from which part of our own, much older and more familiar world you are joining us tonight. Please write your city or country in the comments below. It is a wonderful way to feel our shared human connection as we prepare to look upon the dawn of all things. And if you enjoy these calm and deep explorations into the greatest mysteries of our universe, please consider subscribing to the channel. Your support is the quiet energy that allows these voyages into the unknown to continue, always calmly, always at the pace of the universe. The story of these impossible early galaxies is not just a small academic puzzle. It is a discovery that is shaking the very foundations of modern cosmology. To understand why, we must first understand the story we thought we knew. Our standard model of the universe, a beautiful and incredibly successful theory known as Lambda-CDM, gives us a very specific recipe for how to build a cosmos. It tells us that galaxies should be built from the bottom up. In the early universe, small clumps of invisible dark matter would have acted as the first gravitational seeds. These seeds would have slowly pulled in the great, diffuse clouds of hydrogen and helium gas left over from the Big Bang. Over hundreds of millions of years, these small clouds would have condensed to form the first, small, and rather messy dwarf galaxies. And then, over billions more years, these dwarf galaxies would have slowly drifted together, colliding and merging in a great cosmic dance of construction, gradually building up the larger, more structured, and more massive galaxies, like our own Milky Way that we see in the universe today. The key to this story is that the process is slow, it is patient, it is gradual. And so, when the James Webb Telescope looked back to an era just 500 to 600 million years after the Big Bang, we expected to see the cosmic equivalent of a nursery. We expected to see small, faint, clumpy, and irregular infant galaxies, the very first building blocks, just beginning their long and patient process of construction. But what Webb found instead was the cosmic equivalent of a nursery filled with fully grown adults. It found galaxies that were already as massive as our own Milky Way, galaxies that were already filled with mature, reddish stars, and galaxies that had already organized themselves into beautiful and well-ordered spiral disks. This is the great and profound mystery. The universe, it seems, was in a hurry. It found a way to build great, mature structures far faster than our best and most complete theory of the universe can possibly explain. And this leaves us with a deep and thrilling question. Is our recipe for the universe wrong? Or is there some new, unknown, and powerful ingredient that we have, until now, completely failed to notice? To truly stand in the presence of these impossible ancient galaxies, we must first embark on a journey. It is a journey not across space, but across time, and our vessel is the James Webb Space Telescope. In our last story, we explored the speed of light as a great and absolute barrier, a law that confines us to our own small corner of the cosmos. But tonight, we will see that this same law, this same finite speed, can be a gift. It is the law that turns our greatest telescopes into the most powerful time machines we have ever built. And the principle is a beautifully simple one. The universe is so vast that the light from distant objects takes an immense amount of time to reach us. The light we see from our own sun is 8 minutes old. The light from the nearest star, Proxima Centauri, is more than 4 years old. And the light from the great Andromeda Galaxy, our closest galactic neighbor, has been traveling for more than 2.5 million years to reach our eyes. We can never see the universe as it is, in this present moment. We can only ever see it as it was, in the deep and distant past. The farther we look, the further back in time we see. And the James Webb Telescope is the undisputed master of this look-back time. Its great golden mirror, sensitive to the faint, ancient, and stretched-out wavelengths of infrared light, was designed for one primary purpose: to look so far away, and therefore so far back in time, that it can see the very first galaxies as they were just beginning to switch on in the infant universe. And so, let us now embark on this journey with it. Let us rewind the great cosmic clock, not by a few years or a few million, but by more than 13 billion years, as we travel back towards the very dawn of cosmic time. Our journey backwards takes us past great cosmic milestones. We pass the point 4.5 billion years ago, when our own solar system was just a swirling cloud of gas and dust. We continue on, back to a time around 10 billion years ago, a period known as the cosmic noon, the most brilliant and energetic era in the universe's history, when stars were being born at a furious and prolific rate. The universe in this era was a vibrant and bustling place, filled with brilliant, blue, young galaxies. But we must go further, back beyond this brilliant noon, into the much earlier and much quieter morning of the cosmos. As we travel past 12 and then 13 billion years into the past, the universe around us begins to change dramatically. The great, familiar spiral galaxies disappear. The universe becomes a darker, quieter, and much more uniform place. We are now entering an era known as the Cosmic Dark Ages. After the initial brilliant flash of the Big Bang had cooled and faded into the faint, invisible glow of the cosmic microwave background, the universe was plunged into a long and profound darkness. There were no stars. There were no galaxies. For hundreds of millions of years, the entire cosmos was filled with a vast, silent, and almost perfectly uniform fog of neutral hydrogen and helium gas, left over from the moment of creation. This was a universe of immense and quiet potential, A great, dark, and fertile nursery, where the seeds of the first structures were slowly, patiently, and invisibly beginning to gather in the quiet dark, pulled together by the gentle, unseen hand of gravity. And then, after an immense and patient wait, the darkness was finally broken. This next great chapter in our cosmic story is known as the epoch of reionization, or the cosmic dawn. Deep within the densest clumps of that primordial gassy fog, the first stars began to ignite. These were not stars like our own sun. They were the legendary and still theoretical population 3 stars, the very first generation of stars to ever exist. They were colossal, hundreds of times more massive than our sun, and they burned with a brilliant blue-white and incredibly intense light. They lived very fast, and they died very young, exploding as the first supernovae after only a few million years. But in their brief and spectacular lives, they began a process of profound transformation. Their intense, ultraviolet radiation acted like a great cosmic wind, blowing away the neutral hydrogen fog that had filled the universe for so long, making the cosmos transparent to light for the first time since the initial moments after the Big Bang. This is the era to which we have traveled. We are now adrift in the twilight of the cosmic dawn, some 300 to 500 million years after the beginning of time. The universe is a place of immense, dark voids, and in the densest knots of the cosmic web, the very first small and messy proto-galaxies are just beginning to flicker into existence. This is the great cosmic nursery we came to see, and it is here, in this ancient and primordial nursery, that the James Webb Telescope has looked, expecting to see cosmic infants. And it is here that it has found, impossibly, the fully grown adults. We have journeyed back in our minds to the very dawn of the cosmos, to a time of profound and silent darkness, a quiet, fertile nursery waiting for the first lights to switch on. This is the era that the James Webb Space Telescope was built to explore, and its method for exploring this ancient time is one of profound patience and incredible sensitivity. It creates what are known as deep fields. A deep field is not a snapshot. It is a long and meditative stare. The telescope directs its great golden eye to a tiny, seemingly empty patch of the night sky, a region so small it is like looking at a single grain of sand held at arm's length. And then it simply waits. For hours, and sometimes for hundreds of hours, it remains perfectly still, its mirror gathering every last, faint and ancient photon of light that falls upon it from the edge of the visible universe. It is the cosmic equivalent of leaving the shutter of a camera open for a week in a room that is almost completely dark, just to capture the faint whisper of light that might be there. And in the summer of 2022, when the very first of these deep field images from the Webb telescope was released to the world, the astronomical community, and indeed the entire world, held its collective breath. We expected to see something beautiful. But we were not prepared for the revolution that this first quiet look into the cosmic dawn would bring. The image was a treasure chest of cosmic jewels, a single frame containing thousands of distant galaxies. But as scientists began to look closely at the faintest and the reddest of these objects, the ones that were the most distant and therefore the oldest, a profound and beautiful sense of shock began to ripple through the community. The cosmic nursery was not filled with the infants they had expected to see. To understand what they saw, we must first understand how we measure the age of these distant objects. The key is a phenomenon known as redshift. As the universe expands, it literally stretches the fabric of space-time itself. And any light that is traveling through that stretching space-time is also stretched along with it. This stretching of the light waves shifts them towards the longer, redder end of the spectrum. The farther away a galaxy is, the longer its light has been traveling through this expanding universe, and therefore, the more its light has been stretched, the more it is redshifted. The James Webb as an infrared telescope is a master at detecting this extremely redshifted light. It can see the light from the first galaxies that may have started its journey as brilliant, blue, ultraviolet light, but which has been stretched for over 13 billion years until it is now a faint, deep, and invisible infrared glow. And when Webb looked at the most extremely redshifted objects in its deep fields, galaxies from an era just a few 100 million years after the Big Bang, it found things that simply should not have been there. It found galaxies that were shockingly bright and therefore shockingly massive. The standard story of galaxy formation, the slow, bottom-up process of small things gradually merging over billions of years, predicted that the galaxies in this era should contain, at most, a few million stars. But some of these early galaxies, objects that have been given names like Jade's GS Z13-0, one of the most distant objects ever confirmed, appear to contain hundreds of millions, or in some cases, even a billion stars. There simply does not seem to have been enough time in the young universe for such a colossal amount of gas to cool, collapse, and form so many stars so quickly. The Cosmic Construction Project, it seems, was running on a schedule that was far, far faster than our theories can account for. But the problem was not just their mass. It was their structure. Our models predicted that the first galaxies should be chaotic, clumpy, and irregular messes, the turbulent result of the violent collapse of primordial gas clouds. The formation of a beautiful, well-ordered, and stable rotating disk, like our own Milky Way, was thought to be a process that would take billions of years of slow and gentle settling. And yet, in these first deep fields from Webb, we've found galaxies in this infant era that already show the clear and unmistakable signs of being well-ordered disk galaxies. We are not just finding fully grown adults in the cosmic nursery. We are finding adults that are already well-dressed and professionally accomplished. This is the beautiful and profound crisis that the Webb telescope has given us. The observations are clear. The data is unambiguous. These impossible objects are real. They are there. It is not our eyes that are wrong. It is our story. The elegant, well-tested, and deeply believed story of how the universe grew up is, at best, incomplete, and at worst, fundamentally mistaken in its very first and most important chapters. The echo of silence has been broken by the first light of dawn, and that light has revealed a picture that we are only just beginning to comprehend. The universe, it seems, has a secret and much faster way of building its great cities of stars, and the search for that secret is now the most exciting and important quest in all of cosmology. We are now standing in the quiet and beautiful crisis of modern cosmology. The James Webb Space Telescope, our great eye on the infant universe, has shown us a picture that does not fit our theories. It has shown us a cosmic nursery filled with impossibly large and surprisingly mature galaxies, objects that, according to our standard story of the universe, simply should not exist so early in time. A true scientific mystery of this depth is not a failure. It is a precious and wonderful gift. It is a signpost, a quiet and insistent whisper from the universe itself, telling us that our story is incomplete and that a new and more wonderful chapter of understanding is waiting to be written. And so, in the quiet halls of astronomy all over the world, the great and patient work of solving this beautiful puzzle has begun. The journey to understand these impossible galaxies is a detective story, and we will now explore the very first and most promising of the potential clues. The first set of solutions that scientists are exploring are the most conservative ones. They do not require us to throw away our entire and otherwise incredibly successful standard model of the universe. Instead, they ask a simpler question. What if our assumptions about the ingredients of the early universe were slightly wrong? What if we have been using the wrong recipe to describe the messy and complex process of the very first stars and galaxies being born? The first and most elegant of these ideas has to do with the nature of the first stars themselves. In our modern local universe, when a great cloud of gas collapses to form stars, it follows a predictable pattern, a recipe known as the initial mass function. This recipe tells us that for every one huge, brilliant, and massive star that is born, the cloud will also create many, many more smaller, dimmer, and less massive stars, like our own sun, and even more of the tiny, faint red dwarf stars. But the early universe was a very different place. The gas clouds from which the very first stars were born were made of almost pure, pristine hydrogen and helium, the light elements forged in the Big Bang itself. They had not yet been enriched with the heavier elements that are created inside stars and scattered through supernova explosions. And some of our most powerful computer simulations suggest that this pristine, primordial gas might have behaved very differently. It is possible that the initial mass function in the early universe was top-heavy. This means that those first gas clouds may have preferentially formed colossal, supermassive stars, stars that were hundreds or even thousands of times more massive than our sun. These legendary first-generation stars, known as population 3 stars, would have been incredibly brilliant, shining with a light that was millions of times more luminous than the stars of today. So, this first theory suggests that perhaps these early galaxies are not as massive as they appear. Perhaps what the Webb telescope is seeing is a kind of cosmic illusion. A young galaxy containing just a handful of these ultra-brilliant, supermassive first-generation stars would shine with a light so intense that from our immense distance, it would look just like a much larger galaxy made of billions of normal sun-like stars. The galaxy is not an impossible adult. It is a brilliant infant, and its brightness is simply deceiving us about its true and much smaller mass. A second related possibility is that the process of star formation itself was different. Our current models assume that building a galaxy is a slow and relatively inefficient process. Only a small fraction of the gas in a giant molecular cloud actually cools and condenses to form stars over a long period of time. But what if star formation in the turbulent and compact environment of the early universe was a much more violent and efficient process? This idea is known as bursty or episodic star formation. It suggests that a young gas-rich galaxy might have been able to convert a huge percentage of its available fuel into a new generation of stars in a single, short, and incredibly intense burst of creation. If this were true, it would allow a galaxy to grow up and gain its mass at a much, much faster rate than our gradual, slow growth models would predict. The Webb telescope, in this scenario, might be catching these galaxies in the brief and brilliant aftermath of one of these intense early starbursts, a moment when they are shining with a temporary and unsustainable brightness. And a third, and perhaps most exciting of these conservative solutions involves the great gravitational monsters that live at the heart of galaxies, supermassive black holes. In our standard model, these black holes start small and grow over billions of years. But a newer theory suggests the possibility of direct collapse black holes. In the rare, perfect conditions of the early universe, a colossal cloud of pristine gas might have been able to bypass the process of star formation entirely and collapse directly into a massive black hole seed, an object already tens of thousands of times the mass of our sun. These oversized seeds would then have acted as powerful gravitational anchors, pulling in gas at a furious rate and triggering rapid, massive waves of star formation around them. They would have been the great, impatient architects of the early universe, allowing great galaxies to form around them far faster than would otherwise be possible. These three ideas, a different kind of star, a different speed of creation, and a different kind of seed, are the first and most promising explanations for the beautiful puzzle that the Webb has given us. But what if the answer is not in the recipe for galaxies, but in the recipe for the universe itself? We have just explored the first and most gentle attempts to solve the beautiful puzzle that the James Webb Space Telescope has given us. In the face of these impossibly mature and massive early galaxies, we have considered the conservative solutions. Perhaps the first stars were different, bigger, and brighter than we thought. Perhaps the process of star formation was faster and more efficient in the early universe. Or perhaps the great, supermassive black holes at the hearts of galaxies were born as oversized seeds, giving the galaxies a powerful head start in their construction. Each of these ideas is plausible, and each is being actively explored by scientists around the world. They represent a way to solve the puzzle while keeping the fundamental framework of our understanding of the universe intact. They are attempts to tweak the recipe for the ingredients of the cosmos. But what if these gentle tweaks are not enough? What if the problem is not with the ingredients, but with the fundamental recipe for the universe itself? To understand this more radical possibility, we must first become acquainted with the name of our standard, and until now, incredibly successful cosmic recipe. It is known as the Lambda-CDM model. It is a strange and beautiful name, and it is a kind of shorthand for our entire modern understanding of the cosmos. The CDM part stands for cold dark matter. This is the invisible, mysterious, and slow-moving substance that we believe makes up about 27% of the universe. It is the great, unseen gravitational scaffolding upon which all the visible structures, like galaxies, are built. The lambda is the Greek letter that represents the even more mysterious force known as dark energy. This is the energy of empty space itself, a gentle, repulsive force that is causing the expansion of the universe to accelerate, and which we believe makes up a colossal 68% of the cosmos. The final 5% of the recipe is everything else. It is all the normal, familiar, baryonic matter that makes up every star, every planet, every gas cloud, and every living thing. This is our standard model. It is the great cosmic cookbook from which our universe is made. And the discovery of these impossible early galaxies is now forcing us to wonder if we have gotten this fundamental recipe wrong. The first radical idea is that our understanding of the dark matter might be incomplete. The C in CDM stands for cold. This means our standard model assumes that the particles of dark matter are heavy and slow-moving. And it is this very coldness that leads to the slow, patient, bottom-up formation of galaxies that we have discussed. But what if dark matter is not entirely cold? What if it is instead fuzzy? This is a real and fascinating theory known as fuzzy dark matter. It proposes that dark matter particles are, in fact, incredibly, almost unimaginably lightweight. And because of the strange and wonderful rules of quantum mechanics, these ultralight particles would behave less like tiny individual points and more like vast, spread-out waves. The universe, in this view, is filled with a great, invisible, and fuzzy sea of these dark matter waves. This fuzziness would have a profound effect on the formation of the first structures. It would allow dark matter to form vast, diffuse, galaxy-sized halos very, very quickly, much faster than the slow clumping of cold dark matter. These great, fuzzy halos would then act as the gravitational cradles for the first massive galaxies, allowing them to form much earlier and on a much grander scale than our standard model would allow. A second, and equally profound, possibility is that we have misunderstood the nature of the dark energy. The lambda in our model represents what is called a cosmological constant. It assumes that the density of dark energy is the same everywhere, and that it has been the same for all of cosmic time. But what if this is not true? A new and exciting theory proposes the existence of early dark energy. This idea suggests that in the very first moments after the Big Bang, for a very brief period, the dark energy of the universe was much, much stronger than it is today, before it decayed down to the gentle background level we now observe. This initial powerful burst of a stronger dark energy would have acted as a kind of cosmic accelerant. It would have supercharged the expansion of the very early universe, which in turn would have allowed the dark matter to begin to clump together much, much earlier than in the standard model. It would have, in essence, given the entire process of cosmic construction a powerful and significant head start, allowing the first great galaxies to be built hundreds of millions of years earlier than we thought was possible. These ideas, a different kind of dark matter, a different behavior of dark energy, are just two of the radical new paths that scientists are now exploring. And they all point to the same thrilling conclusion. The discovery of these impossible galaxies by the James Webb Space Telescope is doing exactly what the greatest scientific discoveries are meant to do. It is pushing us beyond the comfortable boundaries of what we thought we knew. It is forcing us to question our most fundamental and deeply held assumptions about the nature of our universe. We are now living in one of the most exciting eras in the history of cosmology, a time when the great cosmic recipe book has been thrown wide open, and we are, with a deep and profound sense of humility and of wonder, beginning to write its next and most revolutionary new chapter. We have now explored the beautiful and complex scientific ideas that are attempting to solve the great puzzle of the impossible early galaxies. We have considered gentle adjustments to our cosmic recipe, and we have contemplated radical revisions to the very foundations of our cosmological model. The conversation is a vibrant, exciting, and ongoing one, a testament to the health and the humility of the scientific spirit. But now, for this part of our journey, let us leave the quiet halls of theory behind. Let us take the data and the dreams and use them to embark on a final and most immersive journey of the imagination. Let us travel not just to the era of the cosmic dawn, but into the very heart of one of these impossible galaxies themselves. Let us try to witness with our own mind's eye what these ancient and brilliant cities of stars were truly like. Our journey takes us across a gulf of more than 13 billion years. As we approach our destination, the faint, reddish, and almost featureless smudge of light that the Webb telescope first captured begins to resolve itself. It blossoms into a vast, swirling, and incandescent object, a city of stars that is at once both beautiful and profoundly alien. Our first impression is one of intense and chaotic energy. Our own Milky Way galaxy is a relatively calm and stately place, a mature and settled city in a quiet phase of its life. But this galaxy, this ancient metropolis from the dawn of time, is a place of furious and violent creation. It is a cosmic construction site, glowing with the brilliant raw energy of its own formation. The light here is different. The dominant color of our own galaxy is a soft yellowish white, the gentle and long-lived light of countless sun-like stars. But the light of this infant galaxy is a brilliant, fierce, and almost overwhelming blue. This is the light of the great, primordial, population 3 stars, burning with a ferocious intensity. They are colossal giants, hundreds of times more massive than our sun, and their surfaces are so hot that they shine with a brilliant, blue-white light laced with the powerful and invisible glow of ultraviolet radiation. The entire galaxy is illuminated by these great, temporary stellar beacons, giving it a vibrant and almost electric appearance. And woven between these brilliant blue stars are vast, glowing clouds of pristine gas, the very fuel from which these stars are being born. These are the great nebulae of the infant cosmos, and they are not the dark, dusty clouds of our own galaxy. They are glowing with an intense, almost impossible light of their own. The powerful radiation from the giant stars is causing the hydrogen gas within them to fluoresce, to glow with a brilliant, deep, and vibrant magenta or purple light. The visual landscape of this galaxy is a breathtaking and dramatic palette of intense electric blues and deep glowing purples, all set against the perfect inky black of the primordial void. As we journey deeper into this city of stars, we realize that it is not only more brilliant than our own, but it is also far more crowded and far more violent. The stars here are much closer together, their gravitational fields wrestling with one another, creating a complex and chaotic dance. And the lifetime of the great, massive stars that dominate this era is incredibly short. They live for only a few million years before they die in the most spectacular of all cosmic events, a supernova explosion. In our own mature galaxy, a supernova is a rare event, happening perhaps only once a century. But in this young, starburst galaxy, they would be incredibly common, perhaps one erupting every few years. The galaxy would be constantly flickering and flashing with these colossal, world-shattering explosions. Each supernova would send a vast and beautiful, but utterly lethal, shockwave of superheated gas and radiation ripping through the surrounding space, triggering the collapse of new gas clouds and seeding the birth of new stars even as it destroys everything in its path. At the very heart of this brilliant and chaotic galaxy, we would find its engine, its great gravitational anchor. Here, a nascent, supermassive black hole is growing at a furious and almost unimaginable rate. It is not the quiet, sleeping monster that lives at the center of our own Milky Way. It is a brilliant and blinding quasar, a vast, swirling disk of gas as large as our entire solar system is spinning around the black hole. Heated to millions of degrees by the intense friction and gravitational forces, glowing with a light that is brighter than all the hundreds of millions of other stars in the galaxy combined. From the poles of this great incandescent vortex, two colossal, lighthouse-like jets of pure energy and radiation are being blasted out into space, carving great, empty tunnels through the galaxy's glowing gas. This ancient, impossible galaxy is a place of almost unimaginable beauty and violence. And it is, we must realize, a place that is profoundly hostile to life as we know it. The radiation from the giant stars and the central quasar would be lethal. The constant, nearby supernova explosions would sterilize any nascent rocky worlds that might be forming. And the galaxy itself has not yet had the time to create, in any great abundance, the heavy elements like carbon, oxygen, and iron, the very substance from which rocky planets and living things are made. This place is not a cradle for life. It is a factory. It is a great cosmic forge, and its beautiful and violet work is to create the elements that will, billions of years later, in a quieter and more peaceful corner of the universe, become the building blocks of a much calmer and more life-friendly galaxy like our own. We have just returned from our journey of the imagination into the heart of one of the universe's first and most impossible galaxies. We have witnessed a place of brilliant, chaotic, and beautiful creation, a great cosmic forge where the very elements of life were being hammered into existence in the hearts of colossal first-generation stars. This brief and breathtaking visit has given us an intimate, close-up view of one of these paradoxical objects, But now, to continue our investigation, we must zoom out. We must pull our perspective back, far back, to see that this one single galaxy is not an isolated island floating in a uniform sea of nothingness. It is, in fact, just one small, luminous dewdrop on a single strand of a vast, beautiful, and almost invisible structure that spans the entire observable universe. To understand how these great galaxies could have grown so large, so quickly, we must first come to appreciate the grand and silent architecture of the cosmos itself. We must become acquainted with the cosmic web. The cosmic web is the largest known structure in the universe. It is the grand-scale distribution of all the matter, both the dark, invisible matter and the normal, luminous matter, across the cosmos. When we look at the universe on the very largest of scales, we find that the galaxies are not scattered randomly, like seeds thrown to the wind. Instead, they are organized in an intricate and beautiful filamentary pattern, a colossal, three-dimensional structure that looks remarkably like a spider's web, or the delicate branching structure of a nerve cell. This is the great skeleton of the cosmos, the framework upon which all of existence is built. Let us explore the different parts of this magnificent and silent architecture. The most prominent features are the long, beautiful strands of the web, the filaments. These are great, winding rivers of dark matter and primordial gas that can stretch for hundreds of millions of light years across the cosmos. The vast majority of the galaxies in the universe, including our own Milky Way, are born, live their lives, and die along these great cosmic highways. They are the bright, bustling, and life-bearing corridors of the universe. Between these long and luminous filaments lie the great, dark, and empty spaces known as the cosmic voids. These are vast, almost perfectly empty regions of space, colossal, spherical bubbles where the density of matter is incredibly low. They are the quiet, silent, and lonely backwaters of the universe. While they make up the vast majority of the volume of the cosmos, they contain very little of its substance. They are the great, dark, and silent heart of the universe. And finally, the most important and most dramatic parts of this great web are the points where the filaments intersect. These are the nodes of the web. These nodes are the great crossroads of the cosmos, the busiest, most crowded, and most massive locations in the entire universe. They are the places where the great gravitational rivers of the filaments all flow together, bringing with them a constant and immense supply of gas and dark matter. And it is in these great cosmic intersections that the largest of all structures are born. The colossal superclusters of galaxies, great cosmic cities containing thousands of individual galaxies, all bound together by their mutual gravity. This beautiful web-like structure is the very foundation of our standard bottom-up model of galaxy formation. The theory was that the great filaments of the web would act as the cosmic highways, gently funneling the primordial gas and the small first-generation dwarf galaxies along their lengths. Over billions of years, these small galaxies would slowly migrate along these filaments, eventually arriving at the great, busy intersections of the nodes, where they would collide and merge and slowly, patiently build up the great massive galaxies that we see today. The problem, the great and beautiful paradox that the James Webb Telescope has presented to us, is that this process should be incredibly slow. The construction of a great Milky Way-sized galaxy at one of the nodes of the Webb should have taken many billions of years. And yet, Webb has found these great massive galaxies already in place, in what appear to be the dense early nodes of this web, in an era when the universe was less than a tenth of its current age. It is not just that the galaxies themselves grew too fast. It seems that the entire cosmic web itself was more efficient, more structured, and far more effective at channeling the raw materials of creation into these great cosmic cities than our models had predicted. The problem might not be with the galaxies, but with the great cosmic highways that feed them. And this pushes the mystery back even further in time. For the seeds of this great cosmic web, the faint initial blueprint of its filaments and voids, were themselves sown in the very first infinitesimal moments after the Big Bang, a result of tiny quantum fluctuations in the primordial energy of the universe, stretched to colossal proportions by the event of cosmic inflation. The impossible galaxies, therefore, are a clue. They are a faint, ancient, and beautiful echo, a message that is telling us that our understanding of those very first creative moments of the universe itself may be the part of our story that is most in need of a new and more wonderful revision. We have journeyed to the very edge of the observable universe and looked back to the dawn of time. We have stood in the imaginary cockpit of a time-traveling spacecraft and witnessed the impossible early birth of the first great galaxies. And we have zoomed out to see the grand and silent architecture of the cosmic web, the vast filamentary structure upon which these first cosmic cities were built. We have been moving through a world of immense, almost inhuman, scales and concepts. And now it is time to bring this story home. It is time to turn our gaze away from the distant ancient cosmos and to turn it inward. What does this beautiful and profound scientific crisis, this discovery of something that should never have existed, truly mean for us as quiet and curious observers trying to understand our own place in this grand and mysterious story? The first and most immediate consequence is a deep and profound recalibration of our understanding of cosmic time. In our human lives, we are accustomed to certain rhythms of growth and creation. We see a tree grow from a small seed to a mighty oak over the course of a century. We see a city grow from a small settlement to a sprawling metropolis over the course of 1,000 years. Our own story of evolution, from the first simple cells to our own complex consciousness, is a story that unfolded over nearly 4 billion years of slow, patient, and gradual change. And so, we naturally projected this same slow and patient rhythm onto the cosmos itself. We wrote a story for the universe that mirrored our own experience. We wrote a story of a slow, bottom-up construction, a process that would require many billions of years to build the great and mature galaxies that we see in our local universe today. The impossible galaxies of the James Webb Space Telescope have shattered this comfortable and familiar timeline. They are a quiet and beautiful reminder that our own human-scale experience is not the only rhythm of existence. The universe, it seems, also knows how to work in a brilliant and furious burst of creative energy. To find a great, mature galaxy as massive as our own Milky Way, already in place just 500 million years after the Big Bang, is the cosmic equivalent of planting an acorn and having it grow into a full, ancient oak tree in a matter of weeks. This discovery does not just break our models of galaxy formation. It breaks our very intuition about the pace of cosmic evolution. It is a deeply humbling realization. It teaches us that the universe is capable of a kind of rapid, large-scale construction that we had until now deemed impossible. This, in turn, opens up a new and breathtaking vista in our search for life beyond the Earth. The story of our own origins is a long one. Our Sun and Earth formed some 4.5 billion years ago, when the universe was already more than 9 billion years old. And it took another 4 billion years of slow, patient evolution on this planet for our own technological consciousness to emerge. But the discovery of these ancient, mature galaxies means that the conditions for life, at least in a chemical sense, may have been in place much, much earlier in the universe's history than we previously thought. These discoveries mean that there were large, stable, and well-ordered galaxies, potentially filled with second-generation stars and the first rocky planets, when the universe was just a tiny fraction of its current age. This opens up a vast, new opening of free galaxies to evolutions from life beyond the Earth, and previously unimaginable expanse of cosmic time in which life could have arisen and evolved elsewhere. It deepens the great, quiet mystery of the Fermi paradox, and it fills the ancient universe with a new and more vibrant sense of possibility. Finally, and perhaps most profoundly, this beautiful crisis is a lesson in the nature of knowledge itself. Our standard model of cosmology, the great and beautiful story that predicted a slow and gradual creation, was not a guess. It was a magnificent scientific achievement, built on a century of evidence and confirmed by thousands of observations. And yet, the universe has shown us that our beautiful story, as successful as it was, is incomplete. This is not a failure. It is, in fact, the greatest triumph of the scientific method. The goal of science is not to create a story that is final and perfect and can never be changed. The goal of science is to create the best possible story that fits the available evidence, and to be willing, with a deep and profound sense of humility, to change that story when the universe reveals a new and unexpected clue. The James Webb Telescope has given us just such a clue, and in doing so, it has not destroyed our understanding. It has invited us to create a new, a richer, and a more wonderful story. It is a quiet and beautiful reminder that the universe will always be more strange, more clever, and more mysterious than our best and most cherished theories about it. We have arrived at a place of quiet and profound humility. We have seen how the beautiful and unexpected discoveries of the James Webb Space Telescope have gently and patiently revealed the limits of our own understanding. The story of the universe, it seems, is not quite as simple or as gradual as we once believed. And in this beautiful and necessary act of scientific revision, we find a new and more mature relationship with the cosmos. We are learning to let go of our need for a simple, linear, and predictable story, and are instead learning to embrace the universe in all of its strange, surprising, and deeply mysterious beauty. And now, as we continue our journey, let us explore what this new and more complex cosmic story means for the greatest of all human questions, the question of our own uniqueness, and the mystery of life itself. The discovery of these impossibly early and massive galaxies has a profound and direct impact on the way we think about the conditions necessary for life. In our older, slower model of cosmic evolution, the universe would have been a profoundly hostile place for its first few billion years. The first generation of stars were massive, violent, and short-lived, and they would have bathed their surroundings in lethal radiation, the heavy elements that are necessary for the formation of rocky planets like our own, and for the chemistry of life as we know it. Elements like carbon, oxygen, silicon, and iron were only just beginning to be forged in the hearts of these first stars. The story we told ourselves was that the universe needed a long and patient period of enrichment, a slow process of billions of years of stellar life and death to seed the cosmos with enough of these raw materials to make a world like our own possible. This led to a natural and somewhat comforting conclusion that a planet like Earth, and therefore life like us, could only have arisen relatively recently in the universe's long 13.8 billion year history. But the existence of these great, mature galaxies in the cosmic dawn turns this entire timeline on its head. The furious and efficient rate of star formation within them means that the process of chemical enrichment also happened much faster than we thought. These ancient galaxies were colossal, high-speed factories for producing heavy elements. They were so active that they would have produced and distributed a significant amount of the raw materials for rocky planets in just a few 100 million years. This means that stable, second-generation stars, stars like our own Sun, surrounded by planets made of rock and metal and water, could have, in theory, formed in these galaxies when the universe was not even 1 billion years old. This is a breathtaking and almost dizzying realization. It opens up a vast, new, and previously unimaginable expanse of cosmic time in which life could have arisen. It means that worlds that are similar to our own Earth could be billions of years older than our own planet. While our solar system was still a formless cloud of gas and dust, there may have been other ancient and perhaps even living worlds, orbiting quiet, stable stars in these great, primordial galaxies. This discovery does not, of course, prove that life exists elsewhere, but it dramatically increases the amount of time and the number of opportunities that the universe has had for the miracle of life to occur. And this, in turn, casts the great mystery of the Fermi paradox, the great silence, in a new and even more profound light. If the conditions for life were in place so much earlier than we thought, then it makes the silence of the universe even more mysterious and even more deafening. It deepens the puzzle, but it also offers us a new kind of comfort. It suggests that our own existence is not a fluke, not a last-minute miracle that occurred just in time. Instead, it places us in a long and ancient lineage of cosmic potential. We are not the first children of the universe. We are simply the youngest, the most recent arrivals in a cosmos that has been ripe with the potential for life for an almost unimaginably long time. This new story gives us a new and more humble place in the cosmic timeline. We are not the central characters, but we are part of a much grander and more ancient narrative of cosmic creation. And this perspective can be a source of deep and quiet peace. It connects us to the very earliest moments of the universe, not just through the atoms in our bodies, but through a shared potential for existence. The impossible galaxies that the James Webb Telescope has shown us are not just strange and distant astronomical objects. They are our own most distant and ancient ancestors. They are the great, primordial cities in which the very materials of our own existence were first forged. And to look upon them is to look upon a photograph of our own great cosmic family in its beautiful and brilliant infancy. We have explored the grand cosmic implications of these impossible early galaxies. We have seen how their very existence forces us to reconsider the timeline of the universe, the nature of the first stars, and perhaps even the fundamental recipe of dark matter and dark energy that governs our cosmos. We have come to appreciate the beautiful and humbling way that a single, quiet observation can challenge our most deeply held scientific stories. But the story of this discovery is more than just a story about the universe. It is also a story about us. The existence of these ancient, mature galaxies shining in the dawn of time has a deep and profound philosophical consequence. It changes, in a quiet and subtle way, our perspective on our own existence and our sense of our place in the great unfolding story of life. For most of our scientific history, the story of the universe has been one that seemed to place our own existence and the existence of our Earth in a very special and very recent moment in time. The old, slow growth model of the cosmos told us that the universe needed a long and patient period of preparation before a world like ours could even be possible. It needed billions of years for the first violent, massive stars to live and die, forging the heavy elements like carbon, oxygen, and iron in their hearts and scattering them across the cosmos. It then needed billions more years for these enriched materials to gather together to form second-generation stars like our Sun, and the rocky, terrestrial planets that orbit them. This long and drawn-out timeline naturally led us to a conclusion that a planet like Earth, and therefore that life like us, could only have arisen relatively recently in the universe's 13.8 billion year history. We saw ourselves as the late bloomers, the cosmic newcomers, arriving on the scene only after the universe had spent a vast amount of time making the stage ready for us. But the impossible galaxies of the James Webb Telescope have given us a new and much grander story. The furious and incredibly efficient rate of star formation within these ancient cosmic cities means that the process of chemical enrichment also happened much, much faster than we ever thought possible. These galaxies were not just building stars, they were colossal, high-speed factories for producing the very elements that are necessary for life. They were so prolific that they would have produced and distributed a significant quantity of these raw materials in just a few 100 million years. This is a breathtaking and almost dizzying realization. It means that stable, second-generation stars not unlike our own sun, surrounded by planets made of rock and metal and water, could have, in theory, formed in these galaxies when the universe was not even a billion years old. This single insight opens up a vast, new, and previously unimaginable expanse of cosmic time in which life could have arisen. It means that worlds that are similar to our own Earth could be billions of years older than our own planet. While our own solar system was still just a cold and formless cloud of gas and dust, there may have been other, ancient, and perhaps even living worlds orbiting quiet, stable stars in these great primordial galaxies. This discovery does not prove that life exists elsewhere, but it dramatically expands the arena, both in space and in time, in which the great and quiet miracle of life could have taken place. It tells us that our own existence might not be such a recent and unique event after all. And this, in turn, casts the great mystery of the Fermi paradox, the great silence, in a new and even more profound light. If the conditions for life were in place so much earlier than we thought, it makes the silence of our modern universe even more mysterious and even more deafening. It deepens the puzzle, but it also offers us a new kind of comfort. It suggests that our own existence is not a strange fluke, not a last-minute miracle that occurred just in time. Instead, it places us in a long and ancient lineage of cosmic potential. We are not the first children of the universe. We may simply be the youngest, the most recent arrivals in a cosmos that has been ripe with the potential for life for an almost unimaginably long time. This new story gives us a new and more humble place in the cosmic timeline. We are not the central characters, but we are part of a much grander and more ancient narrative of cosmic creation. And this perspective can be a source of deep and quiet peace. It connects us to the very earliest moments of the universe, not just through the atoms in our bodies, but through a shared and ancient potential for existence. The impossible galaxies that the James Webb Telescope has shown us are not just strange and distant astronomical objects. They are, in a very real sense, our own most distant and ancient cosmic ancestors. We have now arrived at a new and beautiful vantage point in our journey. The discovery of these impossibly early galaxies, these great and ancient cities of stars, has done more than just challenge our scientific models. It has gently and profoundly recalibrated our own human place in the great cosmic story. The knowledge that the conditions for planets, for chemistry, and for life may have existed billions of years earlier than we ever dreamed transforms our entire relationship with the universe. It invites us to move from seeing the cosmos as a vast, empty, and mechanical place to seeing it perhaps as a great, living, and biological one. For most of our scientific history, The dominant metaphor for the universe has been that of a machine. From the clockwork universe of Newton to the complex mathematical models of today, we have seen the cosmos as a beautiful, orderly, but ultimately non-living system, governed by impersonal laws. In this story, life is a strange and beautiful accident, a rare and perhaps unique chemical fluke that occurred on one small planet. In a universe that is otherwise sterile and indifferent, it is a story that can often leave us feeling profoundly and existentially lonely, a brief and flickering candle of consciousness in an immense and overwhelming darkness. But the discoveries of the James Webb Telescope are beginning to offer us a new and more hopeful metaphor. The picture that is emerging from the cosmic dawn is not one of a slow, sterile, and mechanical process. It is a picture of a universe that was surprisingly eager and efficient at creating the conditions for complexity. The rapid formation of these massive galaxies, the furious and prolific creation of heavy elements within them, and the subsequent possibility of ancient, life-bearing worlds all point to a cosmos whose fundamental tendency may not be towards emptiness, but towards structure, towards complexity, and perhaps even towards life. This new story invites us to see the universe not as a great dead machine, but as a great fertile garden, a place whose very nature is to bloom. This simple shift in perspective has a profound effect on our sense of home. For all of our history, our home has been the Earth. The rest of the universe, the vast and cold expanse beyond our blue and white atmosphere, has been away. It has been the great, dark, and hostile wilderness. But to know now that the galaxy is likely filled with other ancient cradles for life, other potential oases in the cosmic desert, changes the very meaning of the word home. The Earth is still our home, and it is more precious than ever. But our neighborhood has suddenly and beautifully expanded. The entire galaxy can now begin to feel like our home in a much larger sense. We are like an islander who has spent their entire life believing that their small, beautiful island is the only land in the entire world, and who has just seen, for the first time, the faint and distant silhouette of a vast continent on the horizon. Our island is still our home, but our world has become infinitely larger and infinitely less lonely. This new sense of a living cosmos also gives us a new sense of responsibility. If we are the sole accidental inhabitants of a dead universe, then our actions have a purely local and selfish significance. But if we are one small and very young branch on a vast and ancient cosmic tree of life, then our sense of purpose can begin to change. It instills in us a deep and quiet duty to protect and to cherish our own precious branch of this great tree, our own unique biosphere, and it instills in us a sense of profound and humble respect for all the other unseen branches of that tree that may exist in the darkness between the stars. And finally, this new perspective can transform our own personal search for meaning. The story of a lonely, accidental consciousness in an empty universe can often lead to a feeling that we must create our own meaning from scratch, that we must shout our own small purpose into a silent and indifferent void. But the story of a living universe suggests that meaning may not be something we have to invent, but something we can participate in. We are part of a great, unfolding story of cosmic life, a story that is billions of years older than we are. And our purpose, our unique and beautiful role in this story, is to be the part of the universe that can finally begin to understand and to appreciate it. We are, in a very real sense, the universe's senses. We are its consciousness. We are its heart. The impossible galaxies have not just given us a new scientific puzzle to solve. They have given us a new and more hopeful context for our own existence, a story of connection, of shared heritage, and of a deep and abiding sense of being at home in the cosmos. Our grand journey is now coming to its quiet and gentle conclusion. We have traveled to the very dawn of time and have returned with a new and profound story to tell, a story that challenges our understanding and expands our sense of wonder. We'd have seen the impossible, ancient galaxies that shine in the infant universe, and we had explored the beautiful and complex ideas that are now blossoming in the world of science as it seeks to understand them. We have seen how this single discovery has forced us to reconsider the timeline of the cosmos, the nature of the first stars, and perhaps even the fundamental recipe of our universe. And now, in this last, quiet chapter of our exploration, it is time to turn our gaze inward one final time. It is time to gather the gentle, philosophical gifts that this journey has given us, and to carry them with us into the peaceful and restorative sanctuary of sleep. The first of these gifts is a profound and beautiful sense of perspective. The story of these impossible galaxies, these great cosmic cities that grew to the size of our own Milky Way in a fraction of the time we thought possible, is a deep and humbling lesson in cosmic scale. It reminds us that our own human experience of time and of growth is not the only one. The universe is a place of both slow, patient, and gradual evolution, and of furious, rapid, and explosive creation. To know that the cosmos contains these immense and almost unimaginable creative energies can be a source of profound comfort. It can help us to hold our own personal timelines with a little more gentleness. It is a quiet reminder that the universe unfolds in its own time and at its own, often surprising pace. The second gift is a new and more intimate sense of connection. The story of these ancient galaxies is not just a story about a distant and separate past. It is the story of our own most distant origins. These early, brilliant, and chaotic galaxies were the great forges of the cosmos. It was within their first generation of massive, fiery stars that the very elements that make up our world and our own bodies were first created. The carbon in our cells, the oxygen we breathe, the iron in our blood, all of it was born in the hearts of stars that lived and died in galaxies just like these, in the beautiful and violent dawn of the universe. To look upon the images from the Webb telescope is not just to see a distant object. It is to see a photograph of our own great cosmic ancestors. It is to know, in the most profound and literal sense, that we are not just living in the universe, but that the universe is living in us. We are and have always been a part of its grand and unfolding story. And the final, and perhaps most peaceful gift, is the gift of wonder. This entire journey, this entire scientific mystery, is a testament to the fact that the universe is, and will always be, more surprising, more complex, and more beautiful than our best and most complete stories about it. The discovery of something that should never have existed is not a failure of science. It is its greatest success. It is the moment that the universe gently reminds us that there is always more to learn, always a deeper and more beautiful layer of reality waiting to be uncovered. And to rest in this sense of wonder is a profound form of peace. It allows us to let go of our need for certainty and to instead find our comfort in the beautiful, humbling, and unending mystery of it all. And so now our story is complete. We have traveled to the edge of time and returned with these quiet gifts of perspective, of connection, and of wonder. There are no more questions to be answered tonight. There are no more mysteries to be solved. There is only the quiet, gentle, and peaceful feeling of being at home in a universe that is far grander and far more mysterious than we have ever known. Our long and breathtaking journey to the dawn of time is now complete. We have stood in the presence of the impossible. We have grappled with the profound and beautiful questions that these ancient galaxies have asked of us, and we have returned with a new and more humble sense of our place in the grand cosmic story. We have gathered the quiet and precious gifts that this journey has to offer: the gift of perspective, the gift of connection, and the beautiful, calming gift of wonder. The intellectual part of our journey is now over. The story has been told, and the mind has been expanded. And now, the only journey that remains is the most simple, the most gentle, and the most natural of all. It is the final, quiet, and effortless descent into the deep and healing universe of your own peaceful sleep. And so, as you rest here now, in the comfort and the safety of your own quiet space, you can give yourself the great and final gift of letting go. Allow the story of these great, distant galaxies and all of its vast and complex ideas to gently dissolve. The words and the images have served their purpose. They have been the vessel that has carried us to this quiet and peaceful shore. And now, you can step out of the vessel and rest. There are no more questions to be answered tonight. There are no more mysteries to be solved. There is only the deep and profound silence that the story leaves behind, and the simple, gentle, and present reality of your own being at rest. Let us begin this final, gentle journey by bringing our awareness into the body. Let us start with the very tips of your toes. And from there, imagine a slow, soft, and gentle wave of relaxation beginning to move upwards. Feel this gentle wave as it flows into your feet and then into your ankles, washing away any tension, allowing them to feel heavy, warm, and completely at ease. Allow this soft, warm wave to continue its journey, up into your lower legs, and then into your knees, and then into your thighs. With every gentle breath out, feel your legs becoming heavier and heavier, sinking comfortably and safely into the surface beneath you. You do not need to hold them up any longer. You can let them go completely. Now, feel this gentle, warm wave as it flows into the base of your spine, into your hips, and into your pelvic area. This is the great, stable center of your body, and you can allow it now to feel completely and utterly supported. Let the wave of relaxation continue its slow and patient journey upwards into your lower back, and then into your middle back, and then all the way up to your shoulders, releasing every small knot of tension, every trace of the day's posture, allowing your entire back to melt into a state of deep and profound comfort. Bring your awareness to your stomach and your chest, and just notice the gentle, natural, and easy rhythm of your own breathing, the soft rise on the inhale and the gentle fall on the exhale. This is the quiet, life-giving pulse of your own personal universe. Allow this feeling of deep and easy peace to flow down from your shoulders, into your arms, and all the way to the tips of your fingers. Your arms and your hands have been working for you all day, carrying and holding and doing, and now their work is done. Allow them to feel heavy, warm, and completely still. And now, the final part of this journey. Allow the wave of relaxation to flow up into your neck, releasing the muscles that connect your head and your shoulders. And finally, allow this soft, warm, and gentle feeling to wash over your entire face. Soften your jaw. Let your lips part slightly. Soften the tiny muscles around your eyes, and smooth out the space on your forehead between your eyebrows. Your entire body is now in a state of deep and quiet and profound rest. It is your anchor, holding you safely and peacefully in this present moment. And all that is left to do is to rest here and to float on the gentle, silent tide of your own breathing. You have now arrived at a place of deep and profound stillness. The great cosmic journey is complete. The story has been told, the mysteries have been explored, and your body is now in a state of quiet and perfect readiness for sleep. The mind has been expanded, and the body has been calmed. And now there is nothing left to do, and nowhere else to be. The only journey that remains is the one into the gentle and healing quiet of your own rest. You do not need to seek this place. You do not need to force it. You simply need to allow it to arrive in its own perfect time, like a gentle and welcome tide. And so, you can let go now. Let go of the story of the ancient galaxies. Let go of the thoughts of your day, and give yourself full permission to drift. You are floating now, on a quiet and comfortable sea of peace, drifting gently, deeper and deeper, into the quiet, into the calm, into the wonderful and restorative silence of sleep. Rest now. Just rest. The journey continues, always calmly, always at the pace of the universe.